So I have a lot of information to give you in this video. A lot going on. So first thing, we're going to start looking at graphing quadratic functions. Okay? So, from the past, you know that when you graph a linear function, you get a line. Well, what we're going to work on is graphing a quadratic function, and you'll never guess at what a quadratic function will make on a graph. So I'm just going to go ahead and tell you that on a graph, a quadratic function makes a parabola. So we're going to say quadratic functions are a parabola when graphed. So a linear function is a line when we graph it. A quadratic function is a parabola. So just to make sure you get this, it is parabola. Parabola. Maybe it looks better like that. Parabola. All right? Now, you're probably saying, well, that's fantastic, but what in the world is a parabola? A parabola is a U shape, and it's not a V, it's a U, so it will look like this, or it could look like this. And it can't go right or left since we are dealing with functions. So if you remember the vertical line test, that's when you would put like a vertical line to test to make sure that the function or the equation that you're graphing only hits each vertical line one time. So if it went this way, we can even use our notebook paper lines to see that if we did a vertical line test, it's going to hit it twice. So we are only graphing functions. So we are going to be looking at parabolas that open up and open down. And there's so much information on this topic that's going to be coming in the next week or so. But what we're going to start off with today is finding the vertex and axis of symmetry. So just to clarify what that means, the vertex is going to be the highest or lowest point. So right here, this is the vertex. And for this parabola, it is a minimum point. So if you think back to what we did last unit when we were talking about maximum points and minimum points, that kind of clues in to where we're headed. This one right here is the vertex on this parabola, and this one would be a maximum point. So the vertex is either the maximum or minimum, depending on which direction your parabola is going. And it is kind of like the point that centers the parabola. Because what happens after that is it's an imaginary line right here going through the middle of the parabola. I didn't do a good job over here at all, but we'll just pretend. And what happens is that we have mirror image points. So this point and this point are reflections of each other. And this one should be reflections of each other. So this is what's known as the axis of symmetry. So it's, again, an imaginary line, but that is the axis of symmetry. And since we are dealing with functions, we know that the line that is the axis of symmetry is an x equals line. And it just so happens that the axis of symmetry is going to go right through the vertex of your parabola. So this one is also, I'm going to abbreviate here, axis of symmetry. So it's an imaginary line that cuts the parabola straight down the middle. So we know that the left side of the parabola is a reflection of the right side of the parabola. And so that's why it's an axis of symmetry. So it's a line of symmetry. The deal, again, is that since we are working with functions, our axis of symmetry is a vertical line. And the equation of a vertical line is x equals whatever. And that all depends on where the vertex is located. So the vertex and axis of symmetry are basically the same. All right, so what we're going to do now is go through how to find the vertex and axis of symmetry in the 3 different forms that you guys now know. So first thing we'll start with is standard form. So starting with standard form. All right, so standard form. So hopefully you remember that standard form is ax squared plus bx plus c equals 0. All right, we actually don't need the equal 0. We could have y equals also, so either way. All right, to find the vertex when you're in standard form, the vertex is going to be, and you're going to recognize what this is in just a second, negative b over 2a. So if you think about the quadratic formula, we have negative b and then plus or minus the square root of b squared minus 4ac. Well, we've already used the b squared minus 4ac. That was the discriminant, and that helped us determine what kind of solutions we would have and maybe if there's a better way to go through solving it. This is the rest of the quadratic formula that we didn't use before. So negative b over 2a. So what we're going to do is take negative b over 2a, work that out. That gives us the x value of our vertex. And then, as with anything, anytime we know what x is, we just have to fill it in to figure out what y is. So to get the y value, we are going to fill in x and solve. And that will give us our vertex. So we have this form. We're going to do negative b over 2a. We get that answer. We're going to fill it back in for the x, work it out, and then that will be our y value. Now, what happens every single time is once we know what the vertex is, the axis of symmetry is just that value right there. So this is also going to be our axis of symmetry. So what we'll do is once we know what x is, the axis of symmetry is just going to be x equals that number. So that's what we do for standard form. So standard form, so if your equation is in standard form, this is what you're going to do in order to get the vertex and axis of symmetry. All right, next up, let's do intercept form. So when we have intercept form, that basically means that our equation has been factored. So intercept form. So intercept form, excuse me, I'm so sorry. So intercept form looks like y equals a, and then we have x plus or minus a number, and then x plus or minus another number. So it's in factored form. All right, well, when we have intercept form, what's happening is these two answers right here are the x-intercepts of our parabola. So just to go up here to what we were looking at, so when we do intercept form and we get our two solutions, those are the two places where our parabola is crossing the x-axis. So here's what we know about this, is these two points right here are the same distance from the axis of symmetry. So basically all we need to do is figure out where is the middle of these 2 points. And that is where our axis of symmetry is. Once we know where the axis of symmetry is, that's also the x value of the vertex. So then we can fill it in and work it out. So here's the deal. What we want to do is to get the vertex for the x's is going to be the average of the x-intercepts. So what we're going to do is we're going to take our two answers right here and we're going to average them, and that is going to be where the vertex is located. And then, as always, if we want to figure out what y is, we have to fill in the x and work it out. So, fill in x and solve. That will give us the y. And then, once again, once we know where the vertex is for the x value, that is our axis of symmetry, right there. So that's what we need to do if we have our intercept form. So there's intercept form for you. All right, next up, and the fan favorite, is vertex form. So, vertex form. There's got to be a good reason why this is called vertex form. And there is an excellent reason why this is called vertex form. So just to refresh your memory, vertex form is A and then x minus h squared plus k. All right, we love vertex form because the vertex from vertex form is the h and the k. So all we need to do is look right here, and that is the location of our vertex. Now notice that in here it's a negative h, in here it's a positive. So whatever this is, you have to do the opposite. So just pay attention to that. And then, just like above, once we know what this is, that is the location of the axis of symmetry. So once we know what the h is, we know that the axis of symmetry is going to be a vertical line going through that ordered pair right there. So here's how you find the vertex and axis of symmetry, when you are in vertex form. So I'm going to stop the video just for time and do the examples for this in part B.